Alright class, today we're going to be talking about radians in section 3.2. So if we think back to algebra, we dealt with functions in terms of f of x, where x was my variable, y was the output, where x and y were both real numbers. However, when we deal with trig functions, things get a little trickier because we have functions like sine of theta or cosine of theta. All of our functions are measured in degrees, which can be a problem. Because in order to use all of our function knowledge that we have built up already, we need to write our angles as real numbers. So we introduce the radian. So for a definition, in a circle, a central angle, which means this angle made here by these two rays coming out of the center of the circle, making an angle theta. The central angle that cuts off an arc length equal to the radius. All that means is the radius, r, and the length of the arc here is also r. Those have to be equal. We define the central angle measure to be 1 radian. So if the central angle theta in a circle of radius r cuts off an arc length of length s, then we measure theta, the central angle, given by s over r. So all that really means is that if the radius and the arc length aren't the same, we have a formula now to figure out what the central angle is, whereas theta equals s over r. That's going to be something you're going to want to memorize, so you are going to want to know this. So let's do an example. If I have a circle with a central angle theta, with a radius of 3 centimeters and an arc length of 6 centimeters, we want to measure theta. Well, we're going to come back to our formula we just talked about. Theta equals s over r. Remember, we want to measure this in radians. So let's draw a picture to start. I have my circle. We're going to cut off an arc length with 2 rays coming out of the center, and this is going to make some angle theta. So I have a radius of 3 centimeters and an arc length of 6 centimeters. So let's just plug everything into my formula. I get theta is equal to s. S is my arc length, so 6 centimeters over the radius 3 centimeters. My centimeters cancel off. This is important. We'll talk about this just a little bit more. So we get that this is equal to 2. Notice that my labels canceled. This is because we get a real number answer. Remember, we talked about last slide how we needed a real number answer to plug into my functions in order to do algebra with them. So it's important to remember radians are a unitless measure. Okay, we're going to dive a little bit deeper into this. We want to create this relationship between degrees, radians, and rotations. So we have that one complete rotation is equal to 360 degrees, or 2 pi radians. Do a little bit of rearranging, and we get that 1 radian is equal to pi over 180. We get this by, if we look at this half of the equality, we divide both sides by 2 pi. My 360 goes to 180, my 2 goes to 1. We get 180 over pi, or we get that 1 radian is pi over 180 degrees. This is going to be a relationship that's going to come in handy a lot, so we want to know that as well. Now, to convert degrees to radians, we just flip it. My apologies, radians to degrees, we just flip it. So let's do a quick example. We want to change 30 degrees to radians. Well, okay, we're going from degrees to radians, so we use this ratio of pi over 180. So I take 30 degrees, multiply it by pi over 180. 30 goes into 180 6 times. So 30 degrees in radians is pi over 6. So let's do maybe the opposite now. We want to convert pi over 6 radians to degrees. we're going to use this new conversion factor of 180 over pi. So pi over 6, we're going to change that back to degrees just to show how we can go both ways with this. So we're going to take pi over 6 times pi over 180. My apologies, got that mixed up with the last ratio we had. 180 over pi. My pi's cancel. 6 goes into 180 30 times, and we get back to 30 degrees. So these two ratios, pi over 180 and 180 over pi, can convert back and forth between degrees and radians. So you're going to want to memorize those for the quizzes and tests and for life, because math is fun, and we always want to remember what we learn in math. So let's convert pi over 5 radians to degrees. We're going from radians to degrees, so if we look back at our first slide, radians to degrees, we're going to use this 180 over pi ratio. So we're going to multiply pi over 5 by 180 over pi. Well, my pi's cancel, and 5 goes into 180 36 times. So we get a final answer of 36 degrees. Okay, so we're going to fill out a table of commonly used radian measures based on degree measures that we normally use. So 30, 60, 90, 45s, 180, 270, and 360. Well, remember, we stated a few slides ago that 360 was 2 pi radians. Well, half of 360 is 180. So we're going to divide 2 pi by 2, just like we would divide 360 by 2 to get 180. So you get 2 pi over 2, or just pi. Now we can divide that by 2 again to get 90 degrees. So we divide pi by 2 again, and we get pi over 2. We can divide that a third time by 2, so we get 90 divided by 2, or 45. Divide pi over 2 again by 2, and we get pi over 4. So in order to get 30 and 60, we're going to use our conversion factors from a few slides ago. So let's take 60 times pi over 180 to go from degrees to radians. Well, 60 goes into 180 3 times, so we get pi over 3. Now to get 30, we can divide 60 by 2 to get 30, so we divide pi over 3 by 2, and we get pi over 6. Again, 0 would just be 0. We can plug that into conversion factor. It's still going to be 0, because we're multiplying a conversion factor by 0, so we always get 0. To get 270, we can think of it in terms of multiplying 90 by 3. So we take pi over 2 times 3, or just 3 pi over 2. This table is going to be something you're going to want to know and memorize and be able to do in your sleep. So take some time to memorize that and really hammer out all of these conversions. So let's do a few different examples. We want to find the exact value of all three of these. So let's start with sine of 5 pi over 4. Well, we can either immediately recognize a reference angle in here, or we can switch it to degrees, find the reference angle, solve it, and then figure out the sine of it because of the quadrant. So let's do the first one by changing it to degrees. So I want to go from radians to degrees, so we need to multiply by 180 over pi. My pi's cancel. My 4 goes into 180 45 times. So I get 5 times 45, or 225 degrees. So now we're dealing with sine of 225 degrees. These are equivalent statements. One of them is in radians, one's in degrees. So you can start and use reference angles with either one. Hopefully we'll get to the point where we can just look at a radian measure and know, oh, this is going to be a certain angle with a certain reference angle. but we'll do some examples. So let's draw this 225 degrees out. We know that it's in between 180 and 270, so we're going to be somewhere in the third quadrant. Since we're in the third quadrant, we know to get our reference angle, we take our angle minus 180. We get 225 minus 180, or a 45 degree reference angle. So let's make our special triangle now. We know that our special triangle with 45, 45, 90 has measures 1, 1, and square root of 2. And remember, this x-axis measure is -1, and the y-axis measure is -1 because we're going left and down. So if I want the sine of 45 degrees now, we know that the sine of 45 degrees is square root 2 over 2. But remember, since we're in the third quadrant, or all students take calculus, I know then that the sine of 225 degrees is negative square root 2 over 2. Okay, let's go to number 3 now. So we can either recognize that 2 pi over 3 has a reference angle of 60 degrees, and that's where we want to get to. But for now, let's convert it using our conversion factor. So 2 pi over 3, we're going to use the conversion factor of 180 over pi. Pi's cancel. 3 goes into 180. How many times? 60. So we get a 120 degree angle. So we'll leave the 2 off for the end and just multiply whatever the cosine of 2 pi over 3 is. At the very end, we'll multiply that by 2. So we cannot forget about this 2 here. We'll do that at the very end, though. So we have the cosine of 120 degrees. Let's draw that out. 120 degrees is in between 90 and 180, so we're in quadrant 2. So since we're in quadrant 2, we take 180 minus my angle, or we get a reference angle of 60 degrees. Make my special triangle. I know that a 30, 60, 90 triangle has angle measures 1, 2, square root 3 in those respective places. And this 1 has to be negative since we're going in the negative x direction. So then we can find out what the cosine of 120 is. It's opposite over hypotenuse, so it is a negative 1/2 since we're going in the negative x direction and the hypotenuse is always positive. So then at the very end, we can't forget about my 2 that we had at the very beginning. So we take 2 times the cosine of 120, which we know now is negative 1/2. Our 2's cancel, and we get negative 1 is my answer. So don't get frightened by that 2 at the very beginning. We can just leave him off until the very end, and then tack him on, multiply, and bada bing bada boom, we're done. So the last one, the tangent of 7 pi over 6. We'll do a quick conversion factor again. 7 pi over 6, we're going to multiply, since we're going from radians to degrees, by 180 over pi. Again, my pi's cancel. 6 goes into 180 30 times. So we get a degree measure of 210 degrees. All right, so let's go back and plug that in and draw that. So we're looking at the tangent of 210 degrees. Remember, 210 is in between 180 and 270, so we're going to be in the third quadrant. So we're looking at a reference angle of 210 minus 180, or 30 degrees. Draw my special triangle. I know that my side measures are 1, 2, square root 3. But remember, since we're going in the third quadrant, my x's are negative. So we get a negative square root 3 and a negative 1 since we're going left and down. So we can immediately figure out then what the tangent of 210 is. It's opposite over adjacent, so we get negative 1 over negative square root 3. When we rationalize, the negative signs cancel and we get square root 3 over 3. Alright, let's do one more example here. We're looking at 4 times the sine of 2x plus pi when x is equal to pi over 6. Now don't let this intimidate you. We're just going to immediately substitute in pi over 6 for x in this equation. So let's write that out. This is equal to 4 times the sine of 2 times pi over 6 plus pi. So this might look a little bit intimidating, but we can really condense this down, this 2 times pi over 6 plus pi, into one radian measure. First off the bat, 2 and 6 cancel and leave me with a 3 where the 6 was, because 2 goes into 6 3 times. So we're looking at now 4 times the sine of pi over 3 plus pi. So we need to get common denominators to combine pi over 3 and pi. So we're going to make pi 3 pi over 3. So we get pi plus 3 pi. So we get 1 pi plus 3 pi is 4 pi over 3. With that, we can substitute that back in. So we get 4 times the sine of 4 pi over 3. Okay, with that, we can draw our angle if we know what 4 pi over 3 is right away. If not, we can go through the conversion factor again. Since we're going from radians to degrees, we multiply 4 pi over 3 by 180 over pi. My pi's cancel again. 3 goes into 180 60 times, so we get a 240 degree angle measure. So 240 is in between 180 and 270. So we're again in my third quadrant. We really like the third quadrant today. So we're looking at a reference angle of 240 minus 180, or 60 degrees. We can make my special triangle again. Now the opposite of 160 is square root 3. Opposite 30 is 1, and the hypotenuse is 2. Remember, we're in third quadrant, so both the x and the y are both negative. So now the sine of 240 degrees, kind of a bad 4 right there, is in the opposite over hypotenuse, or negative square root 3 over 2. Remember, we have this 4 that we have to tack on at the very end. So we're going to multiply negative root 3 over 2 by 4. Two goes into 4 2 times, so we're left with negative 2 square root 3 as my final answer. So don't get intimidated when you have this, when x is equal to pi over 6. Plug it in, simplify as far as you can, get it to one angle measure, and then solve from there. Alright, go ahead and write your summary if you have any questions, and take a look at the homework, page 132 through 33 with those numbers. Come with some homework questions if you have them, and have a great night.